Alright guys, so today we're gonna do something more interesting. The properties of integrals, definite integrals. So let's start the question from problem 1 to 4 given definite integral from 1 to 5 of f of x dx equals to 8 and definite integral from 1 to 5 of g of x dx equals to negative 3. Find the values of the following definite integrals. So first one, we use the the addition property of the integrals. So it equals to from the definite integral from 1 to 5 of f of x dx plus integral definite integral from 1 to 5 of g of x dx. So it equals to 8 minus 3 is 5. Alright, the next one. So definite integral from 1 to 5 times parentheses 3 f of x minus 4 g of x dx. So we can we use the multiply property for the definite integrals. So 3 times definite integral from 1 to 5 f of x minus 4 times definite integral from 1 to 5 g of x times dx. So it's 3 times 8 is 24 minus 4 times negative 3 is plus 12, so it's 36. Next one, so it's definite integral from 1 to 5 of 3gx dx. So we put 3 out of the integral, so 3 times 1 definite integral from 1 to 5 of g of x dx, so equals to 3 times negative 3, so it's negative 9. Alright, last one. So still definite integral from 1 to 5 of f of x plus a half g of x dx. So we still use the addition property of the definite integrals. So definite integral from 1 to 5 of f of x dx plus a half times definite integral from 1 to 5 g of x dx, so equals to 8 minus 3 a half, so it's 2 over 16 minus 16 over 2 minus 3 over 2, so equals to 13 over 2. Our problem 5 to 10 express each integral as single integral. So for question 5, we got the definite integral from 0 to 2 of f of x dx plus definite integral from 2 to 5 f of x plus times dx. So for this one, we know this property if the first upper limit and second lower limit are the same, so they could add together. So it equals to definite integral from 0 to 5 f of x dx. That's it. And the second one, and the number 6, definite integral from 3 to 8 of f of x dx minus definite integral from 5 to 8 f of x dx. So one is from 3 to 8, one is from 5 to 8, so we can probably make some slightly changes for this one. So we can make it to definite integral from probably like 3 to 5 f of x dx, and plus definite integral from 5 to 8 f of x dx, and minus definite integral from 5 to 8 of f of x dx. Because obviously these two will cancel out, so the final answer will be definite integral from 3 to 5 of f of x dx. Because definite integral from 3 to 5 of x dx plus definite integral from 5 to 8 of f of x dx equals to definite integral from 3 to 8 f of x dx. Alright, let's see the question 7. Definite integral from 2 to 9 f of x dx minus 2 to 6 f of x dx. Alright, so for this one, we still do the same. So definite integral from 2 to 9 f of x dx, it could be separate to two parts. definite integral from 2 to 6 f of x dx, and plus definite integral from 6 to 9 f of x dx, and minus definite integral from 2 to 6 f of x dx, and these two cancel out. So the final answer will be definite integral from 6 to 9 f of x dx. Let's see the next question. Definite integral from 5 to 1 f of x dx plus definite integral from 8 to 5 f of x dx. So obviously this two, it's kind of like it's a, if you want to give it to the positive area, you gotta make the whole integral negative. So negative definite integral from 1 to 5 f of x dx minus definite integral from 5 to 8 f of x dx. So we could factor out a -1, so negative parentheses definite integral from 1 to 5 f of x dx plus definite integral from 5 to 8 f of x dx. So it becomes negative definite integral from 1 to 8 f of x dx. And let's see the next one. For question 9, definite integral from c to d f of x dx plus definite integral from k to c f of x dx. This one's a little bit trickier, but it's still pretty doable. So basically know that I mean, it's not really tricky because it's actually a tricky question. So what can we do is we write definite integral down first. Definite integral from c to d f of x dx plus definite integral from k to c f of x dx. We gotta find if there are any properties can be used to these two integrals. So c to d, k to c. C to D, K to C. So C to D, K to C. It's really interesting. What if we make them both negative? If we make them both negative, so negative integral from D to C f of x dx minus definite integral from C to K f of x dx. Oh, that makes sense. So we just factor out -1, so negative parentheses definite integral from it's D to K f of x dx. So it just becomes to definite integral from K to D f of x dx. Let's see the last one. So basically, this one is much easier. So for the first one, we could separate it out to definite integral from c to d f of x dx and plus definite integral from d to c to h and from h to d plus h f of x dx minus definite integral from c to h f of x dx. Obviously these two cancel out and we only left definite integral from h to d plus h of f of x dx. I hope you guys enjoyed the video, and because the integral part is really important for Calc PC, so hope you guys kind of understand it. See you next video.